Welcome back to a new video. In this video, I will look deeper into some creative use of mathematical induction. We will apply mathematical induction on a somewhat strange subject. But you will see there are a lot of things like that just to be able to prove statements. And of course, we're looking at mathematical induction to do that. The case I'm going to look at is what we call the odd pi fight. The odd pi fight is some older statement that has been already used in mathematics, and it's a very good example how to use mathematical induction in a kind of more creative way. The thing is, with the odd pi fight, it's a game where people stand outside or in some space. They're at different distances, so the distance between the people is not the same. So some people are closer to each other than the others. And we look at people who have a pie and they throw the pie to the person closest to them. And of course, we assume that they will hit the person with the pie. We assume that the people throwing are doing that properly, they're good at it, and the people who get a pie thrown at, they don't move, otherwise it would be a different game. Now, of course, they're good enough to hit the person at that specific distance. So that's the game. We have a pie, we throw it to the person who is the closest to us, and basically we always hit that person. Now, what is strange here, when the number of people who are playing the game is odd, we can say that at least one survivor will be there. It means that there is at least one person who is not hit by a pie. This is not the case when there is an even number of people. When there is an even number of people, everybody will be hit by a pie. So there wouldn't be a survivor. Now that's something we are not going to prove. I want to prove that the odd pi fight statement is correct. So when we have an odd number of people standing at different distances from each other, at least one person will survive the pi fight. And survive here means not being hit by a pie. Now, the statement to prove is that there is a survivor whenever the number of people is given by 2n plus 1. So 2n plus 1 is basically the sum or the description of odd numbers. 2n plus 1 is an odd number for any number n that I select. 2 times any integer is always an even integer. So we add 1 to have an odd integer. Now, this runs through the positive integers from 1, and it means that the number of participants is at least 3. You can imagine there is no game when there is only one person. So basically, when there is only one person, the game doesn't exist. So for n equal 1, we will have 3 people participating in the game. Let's look at the basis step. The basis step is when we start from n equal to 1. We have a pi fight with 2n plus 1, basically 3 people, and the basis step is to prove that pi 1 is true. So I made the statement pi related to the pi fight. Now let's have a look at it. 3 people are involved in the pi fight, and they are at different distances from each other. Now let's assume that A and B are closest to each other, since the game states that a person throws the pie to the person closest to them. Since A and B are the closest, the shortest distance from each other, A will throw a pie to B, and B will throw a pie to A. That's the rule of the game. It means that C is farther away from A and B than A and B are of each other. So nobody will throw a pie to C, and C will throw the pie to either A or B, whoever is closer. Now we can do that also in a different way. We can say the same when A and C, B and C are closer. We will see that there is always one person that will survive. So in our example where we said that A and B are closest to each other, in this moment we can say that C is not hit and survives the pie fight. Now this is the element where we have proven the basis step. So once we know that the basis step is true, we can now go to the inductive step. And when we can prove the inductive step 2, we have the proof completed by mathematical induction. Now let's have a look at the inductive step. The inductive step is in fact said that when pi of k is true for any odd integer k larger or equal to 3, which means that there is at least one survivor when 2k plus 1 people are in the fight and stand at distinct distances from each other. So that's what we want to prove. And now we want to show that if pi of k is true, then pi of k plus 1 is also true. This means that there is at least one survivor when there are 2k plus 1 means 2k plus 3 people involved in the fight. It's very important to keep the notions that the people stand at distinct distances from each other. They're not at the same distance, they're at different distances, so basically people throw still to the person who is the closest to them. Now, when we look at the inductive step, we have to consider two distinct cases. The first case is A and B throw pies at each other. So A and B are the closest, they throw pies at each other, and that's a first possibility. Case 2, no one else throws a pie at A or B. They only throw pies to each other. So basically there is nobody else closer to A or B. They're all farther away from A and B than from other people in the game. Let's look at case 1. The inductive step case 1 says A and B throw pies at each other. Somebody else can throw a pie at them too. Because A and B throw a pie at each other and someone else throws a pie at either A or B, it means that 3 pies already have been thrown from a maximum of 2k plus 3. Now, based on this, we see that there are still 2k plus 3 minus 3 means 2k pies left to throw at the remaining 2k plus 1 people. Now here we see we have 2k pies, but there are still 2k plus 1 people. So it means that the people will be hit except one person. So it's only possible to hit at the most 2k pies to the remaining 2k plus 1 people, which means that there is one survivor. So basically the case 1 has been proven by this. Now we can go to the second case of the inductive step. In the second case, no one else throws a pie at A or B. So basically, when A and B throw pies to each other and are not hit by anybody else, there still remain 2k plus 3 minus 2 is 2k plus 1 people to be hit by a pie. So basically what we can say that this complies with the inductive hypothesis that we used before, so that there will be one survivor when there are 2k plus 1 people in the fight, which corresponds with pi of k. So based on this, we can say that the survivor is also not hit by A or B because they throw their pies to each other, and this means that in this case also, in case 2, there is at least one survivor in this case. So basically what we have done now, we have proven the inductive step for case 1 and for case 2. So it means by mathematical induction, we have shown that the statement pi of n is true for all positive integers. So when we have an odd number of participants, whatever n is, we will always have one survivor of the game. So basically, this is the proof that we have been looking for. Now, this was a very interesting, a little bit more creative example, but sometimes we will find that these creative examples are quite useful in some applications. Now, when we look at this, we are almost at the end at the series about the mathematical induction, but a very important thing we still have to do, and we will do that in the next video, is to look at some mistakes that can be made. And of course, I will give an overview of guidelines that you should take into account when you are dealing with mathematical induction. You're doing a great job, and I'm looking forward to seeing you in our next video. Thank you, and bye-bye.